All right, Chem 11. Next topic, stoichiometry involving solutions. On the iPad is a note that I just made up today for you. This is on our D2L page for the course, so download that. If you don't have it, maybe get it before you watch the rest of this video so you can do the problems with me. There are going to be some sample problems. To take part in today's video, you're going to need the Calculator-O-Matic 3000 solar powered edition. So when the zombies knock out the power, this guy can still do chemistry. And the periodic table 3000 double secret probation Mendeleev edition. Never leave home without it. All right, so we'll get into this note. Guess who's back? Of course, stoichiometry is back. We learned about this, stoichiometry, last unit as part of our quantitative chem unit. And stoichiometry was a science of determining amounts within a chemical reaction. So we could determine, a given amount of product was ordered. We could tell you exactly how much of each reactant was required. Or, if I have so much of this reactant and so much of that reactant, you could tell me exactly how much useful product we could make from those reactants. It goes back and forth, right? So we can use stoichiometry to determine the amounts in moles or masses in grams of any reactant or product. Before we could do that, what did we need, right? Was all stoichiometry based on? A balanced chemical equation. That's our first step always. Whenever we do anything stoichiometry, that balanced equation is number one. Absolutely must have it. All right? So, what are we bringing in new? Well, we're bringing in this, molarity. Molarity measures the concentration of a substance in moles per liter. And given that moles, right here, the N is for moles, given that this has moles, we can now throw that in with our stoichiometry, because that's our second step, is to turn something in that equation, one of those substances, a reactant or a product, into moles. If we are given the concentration and the volume of a solution that's involved in this reaction, we can find the moles and then use the mole ratio to find the other reactant or a product or whatever it happens to be that we have to find. All right? So we're going right into some sample problems. All right, so what I'm going to do is I'll read off the problem, then I'll have to move the iPad so that we have our full space here. Now, down here in the corner in the red, these are the steps to solve, and they're the exact same steps that we did when we had stoichiometry the first time. So, number one is the equation. Number two is turn something into moles. Number three, use the mole ratio. And then number four, get your answer. You might have to find the moles of something. You might have to find the mass of something. You might have to find one of these things, the volume or the concentration of something else. So the answer varies depending on what the question asks for. Our questions today ask for several different things. But these first three steps are non-negotiable. A balanced chemical equation, turn something into moles, and there's always got to be a way to turn something into moles, and then use that mole ratio. We know we are head over heels for mole ratios as a reminder. So, our first example, a lab has 500 mils of silver 1 nitrate solution with a concentration of 2 moles per liter. What mass of copper 2 should you add to extract all of the silver metal via a single displacement? All right. Again, have this note ahead of time because I'm going to move this and it'll be easier for you to keep track. So let's move this out of the way. We'll put that there. And let's do this first problem. Let's do it in, we'll use pink and green. All right. So what were we given? Well, we know we're combining something with copper 2 and silver 1 nitrate. Again, as we stated before, the equation is the number one thing I have to do. And it's a single displacement between copper metal and silver 1 nitrate. These are all good formulas. Any metal by itself is by itself. This is a 1 and that's a 1, so that's good. In that single displacement, the metal kicks out the other metal, and because it's copper 2, it will be CuNO3 2 plus Ag, right? The metal kicks out the metal. And so now we just have to balance this off. Copper's okay, silver's okay. Nitrate, 1 going in, 2 nitrate clusters coming out. So let's put a 2 here, and then of course a 2 to balance that off. Step number 1 done. That's my balanced equation. I am going to move my little molarity sign here because I might need this room, and we know what molarity is. It's C equals N over V. Now let's write in what we were given, all right? We were given a volume of this, and it was 500 mils. I can't leave that as milliliters, so I have to change it into liters, and it's half a liter, or 0.5 liters. I know the concentration of this was 2 moles per liter. It said that in the question. And we're looking for the mass of silver that can be isolated from this. All right? So we did step 1, that's the equation. Step 2, turn something into moles. Well, I obviously have nothing here and here, and I'm looking to find that. I'm guessing we can have, there's a way to find moles right here. N is equal to C times V. And I've got the C and the V for the silver 1 nitrate. So N is equal to 2.00 moles per liter times my volume, which was 0.5 liters, and N is equal to 1 mole. Liters multiplied by liters, top and bottom cancel out. It leaves me with moles only. So I have 1 mole of that. Now that I've got something in moles, I can use the mole ratio. Step number 3, right? I'm going to bring that over here. 1 mole times my mole ratio. Now my mole ratio here, it works out nice and easy for me. It's 2 over 2. And that means I have 1 mole of silver. All right? It's a 2 to 2 relationship, so whatever this is the same. This is 1 mole, that's 1 mole. All right? Now I'm going to multiply by the molar mass of silver. And the molar mass of silver is 107.87. And that's not very hard math. 1 times that is 107.87. But now the moles have canceled out, and I'll be left with grams of silver. And that is my $1 million final answer. All right? So pretty easy, right? Molarity, we said, was pretty easy chemistry. And stoichiometry we're used to. We did, a few weeks of that. So now we're just combining the two. And all the molarity has given us is this alternate route of getting moles. Once we have moles, it falls in line with what we've done previously. All right, so there's our answer to sample problem number 1. Pause the video and get that down if you need to. I'm going to bring in our iPad and look at question number 2. And we were able to keep our steps up the whole time there, which is good. All right, keep these intact if I can. All right, bring in the iPad. Example 2. You find 25 grams of barium metal in the prep room and carefully react with 1 liter of water to make a barium hydroxide solution. What is the concentration of that barium hydroxide solution? So, we find barium and we react it with water and we make a barium hydroxide solution. Now remember, and we are given 25 grams of this. And we want to know the concentration. Squared brackets means concentration. We want to know the concentration of the barium hydroxide solution. Now, for my reaction, because step number 1, I'll move that. We got the information down. Step number 1 is the equation. Now remember, this is what barium does to water. There's water. And what barium's going to do, it's going to come over and break this bond, kick out that hydrogen by itself, so it's gone, and barium will take its place. So barium goes with the OHs, and what it does, it actually does that a couple of times. All right, it kicks off because barium can make 2 bonds. So it kicks off a hydrogen off of 2 waters, and we end up with hydrogen gas. So that has to go here. All right? It's a single displacement. That was one of our rules for single displacements, right? So here is our skeleton equation. Let's balance this off. BA is good. 2 H's, 2 and 2 is 4. So we're going to double that up. And that looks like, yeah, that does it. All we need is this 1, 2 right here. All right. I'll do my answer in green. So, step 1, balance equation. Got it. Step 2, convert something into moles. Well, it's got to be this. Oh, sorry. One thing that was given to me, and I'll put it in blue because it was part of the given values. We know we made 1 liter of this barium hydroxide solution. That's important. I got to write that down underneath of my barium hydroxide. Remember, when I do stoichiometry, I try to arrange things in columns for each of the substances. So I'm going to divide this by 137.33. It's mass on the periodic table. Grams divided by grams will cancel, and I end up with 0.182 moles. I was able to turn something to moles. Now I'm going to use that mole ratio. So that's coming over here, 0.182 moles times my mole ratio. My mole ratio in this case, head over heels. The head of the arrow is where there's a 1. Over heel of the arrow where there's also a 1. And that means I have 0.182 moles of the barium hydroxide. Moles is equal to N, right? And I have to find, that's C, square brackets is concentration. So C is equal to N over V. The N I just figured out. The V was given to me in the question, so now I can do this pretty easily. Moles and liters don't cancel out. And when I divide anything by 1, it's the same number. Only it's 0.182 moles per liter. And that is my $1 million final answer for example number 2. All right? So that's the concentration of this stuff right here. Pretty easy stuff, right? I'm hoping anyway. Let's check out example number 3 on our video. What I'm going to do is I'm going to erase this in a moment. So pause the video now if you need to get this down. I am going to erase it so we can do number 3. Thank God I have the whiteboard. All right, example number 3. Let's bring that in here. Show the double displacement reaction that takes place between silver 1 nitrate, so AgNO3, and calcium chloride. And then it says, once I finish off this reaction, which is part A, calculate the volume of silver nitrate. So volume of this is what I got to find. And it says it's 0.105 moles per liter. So I have the concentration of it. That must be added to 25 mils. So that's a volume, milliliters is a volume, of calcium chloride in order to produce the maximum mass of silver 1 chloride. All right. So let's figure this out. I think I forgot to add something in here. You know what? I goofed. There should be a concentration for this. And the concentration for this, I'm going to fix it, but I'm going to put it in. I'll put that concentration in here because I messed up. Stupid sir. The concentration of this was given in my original question. I forgot to type it in here. So the concentration of the calcium chloride was 0.255 moles per liter. I will fix that and I will repost this on the D2L site. All right, sorry about that. It'll all make sense though once I reload it. So, finish off my equation. Double displacement. So I'm going to switch these two metals. Silver and calcium are my metals are going to switch. So silver 1 goes with chlorine, so it'll be Cl. And calcium goes with nitrate, and that's going to be CaNO3 2. And then I have to balance this thing off. So 1 silver, 1 silver. Nitrate, I've got 2 nitrate clusters there, so 2 goes in front of here. And that means 2 silver, so 2 silver. And that looks like it does it. All right, I'll do this one in orange. So I've got my equation done. That was part A. All that. Moles, what can I turn into moles? Right here. There's my source of moles. N is equal to C times V, which is equal to 0.255 moles per liter times 25 mils. Now I can't use milliliters, so I've got to convert that, and that's going to be 0.025 liters. All right, divide this by 1,000. 0.025 liters. Be careful of that. I almost forgot to do until I got to that point. So N is equal to, let's see, liters on bottom and liters on top cancel. When I multiply, I'll be left with moles. And I will have 0.0064 moles. All right, that's moles of calcium chloride. I'm then going to bring that over 0.0064 moles. I'm going to multiply it by the mole ratio. My mole ratio is, remember, even though I've kind of spread it out, it's calcium chloride here. It's going to be 2, the head of the arrows where there's a 2, the heel of the arrows where there's a 1. Head over heels is 2 over 1. And so that's going to be 0.0128 moles of the silver 1 nitrate. Now I don't have room for it, so I would put it here. So what I have to find now is the volume of this. And this is my N, that's moles. And I've got a C, so if I have N and C, I can find V. So V is equal to N over C. My N, I just figured out, it's the 0.0128 moles. I'm going to divide it by the concentration that was given in the problem. And what will happen is my moles will cancel. Moles divided by moles is no more moles. And I'll end up with 0.122 liters, or 122 milliliters, just to kind of put it in perspective. And that's the end of that. That's an easy one, right? We found out our volume, right? Again, this wasn't given in the question originally when I showed it on the iPad. I will fix that and reissue it to the D2L site. And then this will make absolute beautiful sense. All right? Pause the video, get that down if you need to, and we will do the last one, example number 4. All right. So I got to go back and fix 3. I'm going to make a little note of that right here off to the side. Fix number 3. All right. Number 4. It says a 2-liter waste bottle is known to contain lead-2 ions. You add concentrated calcium chloride solution to form a white precipitate. The precipitate is filtered out and we dry it, and its mass is 0.0112 grams. Identify the precipitate and calculate the concentration of the lead-2 ions in the waste solution. All right, so let's do this one. I have a solution that contains lead-2 ions, right? It's an aqueous solution. It says it's a solution in the question. And I add it to calcium chloride solution. so that's aqueous as well, solution. And a single displacement takes place. PB, we know its charge is 2, so it's going to be PbCl2 plus calcium ions in solution. This, if I use my solubility rules, chlorine is a halide, and all halides are soluble except with lead 2. So this is soluble, it's aqueous, but when I put it with lead 2, it becomes solid. It becomes a precipitate. So this is my precipitate. All right? I know that looks like the thing for PowerPoint, but it's precipitate. All right, so let's check this equation out. 1 lead going in, 1 lead coming out. 1 Ca, 1 Ca, and 2 chlorines, 2 chlorines. We got off lucky. This is a good one. All right? And we've identified our precipitate using the solubility rules. So, it said we had a 2-liter jug, a waste bottle that had the lead in it. So I can put the volume of the lead solution there. It's 2 liters. And it said the precipitate, which is this, it's the only solid in here, was 0.112 grams. All right? And what we are looking for is the concentration of this solution, the concentration of the lead ion solution. Number 1, the equation. Did it? It's balanced. Number 2, turn something into moles. I can't turn in this into moles because I need the V and the C. This I can turn into moles. This is just grams. I can divide it by the molar mass and turn that into moles. So that's what I'm going to do. I'll do my answer in pink. So divide it by the molar mass, and the molar mass of lead 2 chloride is 278.10 grams per mole. Grams divided by grams is no grams, and I'll be left with moles. That's good. That's what I need. Turn something into moles so I can use the ratio. And this ends up being a very small number. 1, 2, 3, 4, 4. All right? So it's 0.00004. There's, after the decimal point, there's 4 zeros, and then the number 4. So I'm going to bring that over like that and rewrite it. 0.00004 times my mole ratio. My mole ratio for this one is actually pretty easy. I didn't have to balance it at all. It was already balanced, so it's 1 over 1. And that number stays the same. And this is my N value. That is my N right there. So now I've got the V, I've got the N, I can find C, because we know C is equal to N over V. N is, I figured it out right here, 0.00004 moles. And my volume was given in the question, 2.0 liters. And when I divide that out, it ends up being 0.00002 moles per liter, because neither of these cancels. These units, moles and liters, can't cancel that way. So that's the concentration, square brackets, of our lead ions in the solution. It's this value right here. I'll underline it in a different color. This is our $1 million answer, and that's what this is right here. The concentration of the lead. Even though it's written over here, I didn't have room underneath, right? Anyway, that's everything. That is sample problem number 4. If you want to pause the video and get that down, do so. I'll bring this back up, and that's the end, right? That's as hard as this gets. So stoichiometry involving solutions, if you're good with molarity, and it's pretty easy, and you're good with stoichiometry, I hope so, because we just spent a month doing it, then we should be really good with this. And of course, little Darth Vader Luke action there. I'll let you read that. All the bad dad jokes. Anyway, hope everything was crystal clear. If you have any questions, comments, or concerns, fire them off in the question or comment section below this video, or if you're in my class, reach out to me through Edsby. I'll talk to you soon. Bye-bye.